Hello, geometry. We are ready to do some talking about more and more areas. We're throwing in a little wrench here with circles, and we'll talk about sectors. So we all know we've all had the most fun doing chapter 10, all those circle sections. So remember, just a circle is all the set of all points that are equidistant from the center. You remember that the length from the center to the circle is called r, or the radius. And you have told me several times throughout this year that the area of a circle is equal to pi times the radius squared. If you know the diameter, you know how to find the radius, right? Diameter is equal to 2 radiuses, because if we went the radius this way and the radius this way, that whole length across would be the diameter. So there we go. So let's find the radius of a circle if it's got an area of 295 square centimeters. Round to the nearest hundredth, so 2 numbers after the decimal. I'm just going to jot down that pi r squared. And I am telling you information to put in there. It says that the area is 295. So I'm going to put that in there. 295 is equal to pi r squared. This is a two-step equation. You probably realize if I want to get the r by itself, I've got to get rid of two things. I've got to get rid of the pi and I've got to get rid of the squared. I cannot square root until I get rid of the pi. So I'm going to divide both sides by pi's. I'm not even going to my calculator yet. I am not going to round because that's just going to make a big old mess. So after I do that, I'm going to have whatever that answer is from 295 over pi equals r squared. And we all know at this point, we're going to square root to figure out what r is equal to. R is going to be approximately 9.69 units centimeters. Almost 10. So a couple quick things. You know how I said this in other chapters. I think it was the SOHCAHTOA chapter. Make sure you do your paper and pencil math first. Don't jump right to your calculator. Some people tell me, well, I don't have to show work because I just went to my calculator. Yes, you do. We need to see what you're typing in. That's the whole point. You're telling me the story of what you did to solve this problem. So I'm expecting to see something like this, because you're telling me that you're typing in 295 divided by pi, and then you're going to square root that answer. The second little warning or information that I want to make sure I mention is you're not going to clear out your calculator. Hopefully you have all at this point figured out the answer button on your calculator. Comes in super handy. You don't have to retype a 16-digit decimal or write it down because your calculator will remember it. So do not clear out your calculator after you do 295 divided by pi. Do the square root of the answer. All right, there's that. We got that, right? So now let's talk about sectors. I think of sectors as like an orange slice. That's 3D, I know, but a piece of pizza, how about that? A piece of pizza is a sector. So a sector is a region of a circle bounded by a central angle and the intercepted arc. The two sides of that sector are radii, and then you've got your central angle and your intercepted arc. So, you know how we found the measure of the length of arc whatever in the circle chapter? Now we're going to find the area of that shaded sector region. So the area of the shaded sector region is equal to a proportion. It's going to be degrees over 360 equals sector over pi r squared. This is most likely, I don't like that sector there. I should say the area of the sector, which is most likely going to be x, the area of the sector, over pi r squared. When we did this before, we were doing the circumference, right? We didn't care how much would fit inside. We cared about the distance around the outside. So this proportion should look familiar. Anytime it says to find the area of a sector, that's your big clue that you're going to set up a proportion. Your x is typically going to be your area of the sector. We all know that R is the radius, and just skip that capital A, cross that right out. So we do need to know the radius. We do need to know that central angle. Notice on this diagram, I have got an X degrees right there. I need to know how many degrees out of 360 that sector is taking up. So let's do ourselves a little problem. You're welcome. It is not a diagram given. So a 12-inch pizza is cut into 8 congruent slices. Find the area of one piece of pizza to the nearest hundredth. So let's draw ourselves a pizza. It's square, it's round, not square. I'm going to cut it into 8 even sectors. And I'm hoping that I do pretty good with the congruent sector part of it. Not too bad. You have to pretend. It's a 12-inch pizza. When you order a 12-inch pizza, this is always your diameter. I'm not sure if you realize that, but the 12-inch pizza is the diameter. So from here to here, it's 12 inches. Find the area of one piece of pizza to the nearest hundredth. So if I just eat this one piece right here, this sector, how much of that pizza did I eat compared to the area of the whole thing? So we got to do a little bit of figuring, right? Our big clue, we know we're going to start off with a proportion. I know it's the degrees. So X degrees of that sector over 360 equals X over pi r squared. Do you know the radius of this circle? Well, sure. If the diameter is 12, doesn't the radius have to be 6, right? It's 6 inches from here. Oops, you can't see that color. It's 6 inches from here to here, so that's 6. What's the degrees? How are we going to figure out how many degrees are in that one piece of pizza? I see a side problem coming along. Well, all of these degrees for these 8 pieces are all the same because they're all congruent slices. There's 360 degrees to split 8 ways or between 8 pieces. So I'm pretty sure that means each one's going to be 45 degrees. So that's the number that goes up here. And now, doing my paper and pencil math first, I can cross multiply this guy out. So 360 times x equals, this one's going to look messy, 45 times pi times 6 squared, or if you wanted to do the math and say 36. I know to solve for this x right here, I'm going to have to divide by 360 and divide by 360. Notice all the paper and pencil math first. This is what I'm going to go to for my calculator. I'm going to type in a 45 times pi times 6 squared. Hit equals and divide by 360, and I believe that comes out to a 14.14 square inches. It's area. Area is always squared. I'll jot down this as each sector. We split it 8 ways. So not so bad. Everybody knows how to solve a proportion. Doesn't look too bad. Let's kind of flip through, see what we got here. I think we're good. We've done something like that. The central angle. Good there. Oh, let's look at this one. Find the total area of the shaded sectors. So total is a big clue word in math that means to add. You can add before, you can add after. It's up to you, however you want to do this. Total area of sectors, I know I'm going to have to set up a proportion. I know it's going to be degrees over 360 equals x over pi times radius squared. So what's the degrees of my sectors? Do you want to do this in 2 separate proportions or in 1? I can take this 35 degree sector and I can add it to this 45 degree sector. And I know my total shaded degrees is 80 degrees. I can use that instead of doing 2 separate problems and adding at the end. Radius for this problem would be, this is my diameter, right? The whole length, so 9 has to be my radius. I'm going to cross multiply these guys out. So 360x equals 80 times pi times 9 squared. I know I'm going to divide by 360. That's where I'm going to my calculator now. When I calculate 80 times pi times 9 squared, all divided by 360, I ended up with a 56.6 0.55 square inches just inside those two shaded regions. So that's a pretty big circle if it's 56 is just the 80 degrees or that portion of it. All right, last but not least, shaded regions. I like these ones, right? Shaded regions means we've got a big region and then we're taking out another piece. So let's just talk about this. This is practice with your formulas and then subtraction. We're taking away one area from another. So in number 4, what's the larger area that we'd need to find first? We'd probably need to find the area of that parallelogram or square or whatever that figure is. I'll just call it a parallelogram. I think it's supposed to be a square. Actually, it should be a square if it's fitting around that, because all these segments are congruent. So let's call it the area of a square, and let's say I did a really bad job cropping it. So the area of the square, and then what are we taking away from it? The area of the circle. Do you know how to find the area of a square? Right, base times height. Do you know how to find the area of the circle? Pi r squared. And then we can go from there, subtract those two values. Number 5 is an interesting problem because, first of all, what's your bigger figure that you're going to find first? Probably need to find the area of the circle, and we're going to subtract the area of that triangle. Well, we don't actually know the radius or the diameter, right? Pi r squared is our area of a circle. So I'm probably going to have to do some figuring. I know it's a little blurry up here, but I notice that I've got congruent dashes on both of these little sides. So it's 5 square roots of 2, 5 square roots of 2. I also know, because this is a diameter, that I've got myself a right angle right here. So I could do Pythag to figure out what that diameter or that hypotenuse is. So 5 side problem, 5 square roots of 2 squared plus 5 square roots of 2 squared equals x squared. You've got a calculator to do this for you, but if you're really watching, 5 squared is 25, square root of 2 is 2 squared. 5 squared is 25, the square root of 2 squared is 2. So that's going to be 50 plus 50 equals x squared. Well, this one's really easy. If x squared equals 100, this has to be 10. I now know everything I need to figure these two things out. So the area of a circle is pi times the radius squared. We just found the diameter, right? So pi times 5 squared minus my area of my triangle is base times height, all divided by 2. With this right angle here, the base is 5 square roots of 2 and the height is 5 square roots of 2. So 5 square roots of 2 times 5 square roots of 2 all over 2. Put those guys in parentheses. Do each problem separately. I probably need to grab my calculator. I'm going to round to the nearest hundredth. So, and don't forget to use your pi button. So pi times 5 squared. That circle has an area of about 78.54. The triangle has an area of, that's going to be 25 times 2, 50. I believe that's going to be 25, but let me just double check and make sure. Yeah, I got a 25 on that one. Double check your math. Let me know if you have any trouble. So 78.54. I'm taking out that triangle. I've got a final area for the shaded region of 53.54. So these problems are just a lot of the formulas we've done. We just keep mixing them up, putting them together, recycling, reusing, putting things in, doing Pythag, doing side problems. All right, so that is it for section 11.3. Whoa, I was confused. Have a great one. Come in with questions, and we'll talk next time.